In this video, we'll go on to constraints on relational databases. So there's two kinds of constraints. Schema-based constraints that you can express in the model, like we could express certain kind of constraints in the ER model. And in the relational model, these schema constraints are enforced by the relational database management system that you use. There's other kind of constraints too. They're called application-based constraints or business rules, and those are enforced by outside software or other means. Sometimes the database management system can do that for you too. A good example of an application-based constraint is like in the conference review system. A rule was that a reviewer wasn't allowed to review their own paper. So that's not part of the model. It wouldn't be part of the relational model either, but it is an application-based constraint. So let's talk about the model-based constraints, the ones that are part of the relational model and are enforced for you by your system. The first one is domain constraints. So that says that all attributes have to be a member of their defined domain. Usually it's a data type, so integers must be in integer attributes and so on. There's also smaller domains, and those can also be enforced by the database. The next constraint is a key constraint. So a relation, as we had said, is an unordered set of tuples. It's also an unordered set, of course, that has no duplicates. So we need to think about the key attribute just in a similar way as we thought about the key attribute in the ER model. So let's get some definitions about keys. So there's this thing, a super key. A super key is a set of attributes who all together form a key. It doesn't mean that they necessarily form the key. They do form a key. So a super key of one table always will be the entire set of attributes, because every row is unique. So the whole set of attributes of the whole table form a super key. But that's not so interesting, that all the attributes combined. Instead, we want to think of keys. And a key, the strict definition of a key is a minimal super key. It's a super key who, if you take away one of the attributes that are in that super key, it will no longer be a key. Let's see an example. An example of that could be, many of you made a review entity in the conference review system. And if we think of that as a table, we could think that it has the paper ID in it and the reviewer ID. Many of you had a weak entity that was identified by both the reviewer and the paper, and so its unique identifier was the combination of those two fields. So we could say paper 1 is reviewed by reviewer A. Paper 1 is also reviewed by reviewer B. Paper 2 is reviewed by, by reviewer A, and so on. So if we think of this, the combination of paper ID and reviewer ID as a super key, together there's no duplicates, 1A, 1B, 2A. Those are all distinct. But if we remove either one of those attributes, then there are duplicates. We can see already there's 2 A's here, there's 2 1's in the paper ID. So alone they're duplicates, but combined there aren't. So a minimal superkey of this table, if we made it a table, would be the paper ID and reviewer ID together. Now, in one table, in one relation, there can be a number of minimal superkeys or multiple different attributes or sets of attributes that are technically keys. And we call all of those candidate keys. It means any of them could be chosen as the key. But for each table, we choose just one. And the winner of that election is called the primary key. And you just choose it based on the one that's most natural. There's some other reasons to choose one key over another, which we'll talk about in the future. So primary keys in the relational notation are underlined just like they are in the ER model notation. The key attributes are underlined, but in the relational model there is only one primary key. Okay, so let's talk about more types of constraints, integrity constraints. So there's one kind of integrity constraint. It's very simple. It's called the entity integrity constraint. And that constraint says that a primary key or even one attribute in the primary key can't be null. And the reason is primary key must be unique, so it doesn't make any sense that some part of it could be unspecified. What would the meaning of no value be in testing something's uniqueness? It's not possible. So if something's defined as a primary key, one attribute or one set of attributes, not only must they be a unique value there, but no part of it can be empty. Then there's one more type of constraint, and maybe the most important type, because we've talked about the relational model, but we haven't talked about how in the ER model we had relationships. So how do we make relationships between tables in the relational model? Well, you do it by using this concept of a foreign key. So a foreign key in a table establishes a relationship to another table. So a foreign key in one table must be a partner of a primary key in another table, and that combination of foreign key, primary key says there's relationship between these two tables. And the two values matching says there's a relationship between these two rows, the ones that have matching values for the primary key and the foreign key. And formally, referential integrity tells us that a foreign key must have the same domain as the primary key it refers to, so they both have to be the same type of attribute, and that in the table with the foreign key, that attribute or set of attributes value must either be null or match an existing value of the primary key in the other table. So let's see some example of what that means. So remember, we had set up our two tables, the doctor table and the patient table. And now let's imagine that our doctor table has some values in it. It has the ID, name, and specialty attributes. And in our doctor table, we have two doctors, Dr. 123 and Dr. 145. So now we see what we put into the patient table, because we remember that the patient and doctor table had a relationship in the ER model, that a patient has one doctor who's their primary doctor, and the doctor has one-to-N relationship with the patient. So one doctor can have many patients who they're the primary doctor of, but the patient only has one primary doctor. Since the patient has just one primary doctor, we can make this foreign key right here. So this attribute and this attribute that it refers to, and you see the directed arrow here pointing from the foreign key to the primary key, they both have to have the same data type. Let's say it's an integer here because I put numbers. And the patient can only have a primary doctor ID of a doctor that exists. So for this patient, maybe their primary doctor is Dr. 123. And that's legal. If you tried to add a patient into your database and you tried to put their doctor ID as 257, then you would get an error, because that would be a violation of relational integrity, because we can see, is Dr. 257 in the doctor table up here? No. So it's not a legal value for the primary doctor ID in the patient table, because primary doctor ID is a foreign key related to the doctor ID. So in the next video, we'll talk about how ER and relational models map to one another, and then we'll see a lot more examples of foreign keys. Okay.